in the part process instrumentation and control, I'll be discussing or covering mainly the control aspect. Okay, so I think you have a particular course in linear control systems, right?
Yes, sir.
Gone through the basics of control system, but I just want to reiterate the fact that in this process instrumentation and control, the control part will not be just like your control system lectures, because there you have learned some tools and theorems, and some mathematical tools to analyze, to synthesize systems for the stability and their performance, and to design controllers, I guess. So that is a bit based on a mathematical aspect or mathematical perspective. But in process instrumentation and control, we shall discuss the application oriented control. Okay, we'll discuss different fields of process industry and see how the control and different modes of control will be applied. In this regard, the different types of control applications and different types of controllers will be introduced with their basic principle and their applications, their drawbacks and advantages, that is merits and demerits, that will be discussed. Since you all know that in control system design, analysis, synthesis, whatever you term it, the main part is the mathematical modeling. So in all this process controlling also, in process control also, we'll first discuss about the mathematical modeling of a process. Okay, then we shall proceed to different control algorithms and controllers. So before I start, I just want to ask a simple question. If I ask you a question that what do you mean by control system, or what is control system, can you answer? Anyone? Say from section A, anyone? What is control system?
The system that processes from the input to the output based on a relation.
ওকে, অনিশ আরেকবার রিপিট করো, এই সেকশন বলছিলাম শুনতে পাইনি, অনিশ বলো।
বলছিলাম that the system that processes the input to the output based on a mathematical relation.
Okay, actually the problem is both of you are correct, that's okay, but I think I want a more generic definition of control system, more generic. You are all giving your definitions in respect of some system engineering point of view, but there can be a more generic definition of a control, because say control is not only related to engineering field or system engineering field, there are other definition or other aspects of control, right? Say for example, we control our emotions, we control our attitude, we control our behavior. So these are also control, no? So if I want to emphasize on the term control, then what would you say? By term control means, so from layman's point of view, can I say that the control is to make a given system behave in a desired manner. Here, the system doesn't mean necessarily any physical system. It may be a mental state, it may be anything else. But you have an intention to make it behave in a desired manner. Then what you need is a control, what you call a control. Now, coming back to the system engineer's point of view, when you are talking about from an engineering point of view, then you can say control system is a mean by which any quantity of interest in a system can be manipulated or altered in accordance with a desired manner. Okay, from engineering point of view. Do you, all of you agree with that?
Yes, sir.
Okay, so this is a basic or not basic, this is a fundamental aspect or fundamental requirement of control. That is, you have to have some desired manner that has to be followed. So for that, what you have to do, you have to manipulate or alter some of the quantities in a system or some of the parameters in a system, so that the system behavior response follows a desired path. Then the next question is, if I tell you to classify control system in the most broad category, how do you classify a control system in the fundamental categories? Two categories, I'll give you a hint. Right, open loop control and closed loop control. So can you discuss anything on this too? What is the merit and demerit of open loop control and closed loop control, and whichever control would you prefer in a process industry?
In open loop control, feedback won't be there, and closed loop control, feedback will be there.
Fine. What is the advantage of having a feedback?
Feedback may control the process, may control the output value, or may lead to a desired output value.
Actually,
Open,
open loop control, although it is easier and simpler, in closed loop control, since we get a feedback, it automatically we can reach the desired output. Whereas in case of open loop control, it is not automatic. It has to be controlled from the input.
right, right. Now the thing is that the main term that he has mentioned is that automatic. That closed loop control is basically automatic control where you have a feedback from the output, which is then compared with the desired input, and it automatically takes care of any discrepancy in these two values, or any deviation from the desired value can be taken care of automatically. That is why closed loop control is called an automatic control. Whereas in open loop control, your open loop control system may operate in very accurate with accurate results under ideal conditions. In case of any disturbances, the term is very important. Any disturbances, in case of any disturbances, or in case of any parameter changes or any change in environmental situation, the output may deviate. But since in open loop system there is no provision of having any information regarding the output, so you cannot have any expectation of having the system to automatically adjust its values to get back to the desired value. So what will happen in case of any disturbances occurring in the system? For open loop system, the output will surely deviate from its desired value, so you will not achieve the desired value under the influence of disturbances. Whereas in closed loop system, these disturbances can be mitigated. The effect of the disturbances can be mitigated by mere presence of the feedback. So this is the advantage of the feedback. So most of the control systems that we will be discussing will be feedback control systems. And open loop control systems are very rarely used or almost not used in control system because of these discrepancies. Now, other important aspects of closed loop control that I just want to reiterate is that in open loop control, to achieve a desired performance to a level of accuracy, what you need is an accurate mathematical model of the system. Then only your open loop controller can be designed accurately and you will get the accurate response. Whereas in feedback control system, even if you have an inaccurate model, that is, the model may contain unmodeled dynamics or unmodeled system equations or some uncertainties in a system model, then also it may follow the desired response by means of the fact that the feedback will take care of such limitations of modeling. So any inaccurate model can be used in a feedback system to obtain a desired response, but that is not possible for open loop system to obtain accurate model using accurate response using an inaccurate or insufficient model data. So for that, the closed loop system will be obviously advantageous, and it will get rid of that laborious modeling process. Even if you get a simplified model using a feedback control system, the modeling discrepancy will be taken care of by the mere use of the feedback, right? Whereas in open loop systems, since there is no feedback, and any unmodeled dynamics or inaccurate modeling will lead to a deviation in the actual response. Mathematically or theoretically, you may get actual accurate response, but whenever you're implementing that, since the model and the actual plant has a lot of differences, so you cannot expect in an open loop system that output will be same as the desired one. So in that case, we have to retune the open loop controller. That's why the open loop control aspect is not very much used in this process control field. So everything is closed loop control. But again, I think you should have this idea also that although this closed loop control system has so many advantages, it has a major drawback. That is, a closed loop system or the introduction of closed loop can cause a physical system which is in all sense a stable one to may become unstable if the feedback is not suitably designed. This can be judged if you see the from the say root locus point of view. If you have a system which has a relative order 3 or more, then there will be root locus branches will be crossing the imaginary axis, right? So at a particular, after a particular value of gain, one or two or more, at least two of the roots will be passing over to the right of plane. The system will become unstable. So there will be a limitation. Whenever you're designing a feedback control, you should also keep in mind that there is a certain limitation for certain systems regarding the stability margin. That is called the stability margin. So there is a possibility. So all is not very positive in respect of feedback systems. Okay, so this point should also be noted that in some situations the feedback, if not properly designed, may lead to unstable system. Okay, or system instability. So this is the only drawback of a feedback system. Okay, now coming to another fundamental definition, I think this should be cleared at the first instant, that we have three different definitions. That is, one is called a plant, one is called a process, one is called a system. So in some books or some references, you will find the term plant. Some cases you will find the term process. Some cases you will find the term system, where you have to design a control. Okay, so design a control system, you will be given a plant, you will be given a process, or you will be given a system. So do you understand this difference between the plant and a process and a system? Are they all same, or are there any differences? Any idea?
No, sir.
So mathematical functions that has been suppose implemented will be basically by the plant. Means plant will provide that mathematical, or we can say that transfer function, I guess.
No, transfer function can also be termed as system, or process is not very much used. System and plant are used interchangeably. Okay, let me put some light onto the fact. See, first of all, if I start with the statement that basically system is a more holistic definition of physical elements, and plant and process are the subsets of a system. How? Now, if I define a plant, what a plant can be defined as? A plant may be a piece of equipment or just a set of machine parts which functions together for the purpose to perform a particular operation. That is, it is basically a piece of equipment, obviously physical equipment or a machine part that functions together, or a group of equipments that functions together, and the purpose is to perform a particular operation. So any physical object that is to be controlled can be termed as a plant. Okay, whenever you're trying to control the speed of a DC motor, the DC motor will be a plant. The position control system, the position servo will be a plant, because there's a physical element involved. In some situations, you may have to design a control system for economical growth or economical stability. Then there is no physical system. You cannot term the economical system as a plant. You can term them as a system. Okay, but you cannot term that as a plant because there's no physical elements to it. Okay. Next is a process. Now, what is a process? A process, if I say in the layman's word, is whenever a particular sequence of operations are to be followed, keeping in mind that there is no provision of breaking the sequence. So you have to follow a particular sequence of operation, and sometimes the sequence of operations are time dependent and time driven. That is, one operation should succeed the another, and there is a particular time frame given for every operation, just like a batch processing in an industry or a factory. So this, from starting from one end, input end, to the final product, this entire thing is basically a sequence of operations. And whenever you have a sequence of operations and you have to control this entire thing, then you call that a process. It also contains physical elements. You could have called them a plant. But since the total operation consists of a sequence of operations, we rather call them a process. So if you want to control a particular part, suppose a grinder is there, you want to control the grinder only, then you can say the grinder is a plant for which I am designing a controller. That is okay. But when you are considering the whole system, I can use the term system whenever I wish, because it's a more generic one. So whenever you consider the whole system for which a control system is to be designed, then you can say it's a process system, or it's a process, simple process. And in this course, we will be concentrating on such processes. Okay, where there will be sequence of operation that has to be maintained and ensured, and each of the sequence will be dependent on the previous sequence, and each of the sequence will be providing the input for the next sequence of operation. So it's very important that each and every process is controlled either individually or in a holistic manner, right? So any operation to be controlled will be termed as a process. It may be chemical process or whatever. So at the concluding term, what is the system then? The system will be a combination of components that act together and perform certain objective. So in this case, this definition is not limited to physical ones. It may be economical, it may be educational system, anything. So a system can be, as I've already mentioned in the signals and systems, in the systems part, that system can be anything under the sun. Anything under the sun that you can want to control, want to study, can be termed as a system. Because this portion of the engineers, the control engineers, they are called the system engineers, because they work with these systems and design control for them. They synthesize the control for such systems. Okay. Now the next important thing, so we have already defined three terms: plant, any physical equipment, physical say machine or something that you want to control, plant, any process or a operation, a sequence of operation that you want to control is a process, and system can be anything under the sun. Anything under the sun can be termed as a system. But I'll prefer that whenever you're trying to define a system, you either define it as a process or a plant. Then the ideas will be much clearer, right? So whenever designing a control system, the next important thing that we should always keep in mind is a disturbance. Okay, so this disturbance plays a very important role, especially with respect to process control, because in process control, since I've already mentioned it is widespread. It starts from one position, it ends at another position. It's time dependent. There are a lot of individual processes taking place. Then you obtain the final result. And since you have to maintain productivity and a quality throughout this chain, there may be different instances where a disturbance may occur. Now, what is a disturbance? A disturbance is nothing but any unwanted input or unwanted change in the condition that may lead to a deviation in the final result. Okay, so there may be different forms of disturbances. Okay, we'll discuss about that disturbances when we'll discuss about the process more intensely, right? So from control point of view, what will be our objective? Given a process system, we'll have to first obtain the mathematical model, and then we have to study the stability of the system, and then we need to design a controller, suitable controller, given some performance criteria to be met, right? Now coming back to the now we are concentrating only on the process control, that is the control of processes. Now the question that you may ask, that why this process control is so important, and what is the need behind this process control course, or why this is so important. So other than, I think I did not show anything, I'll just discuss, I just put some thought onto your mind. Let us try that why this process control is so important. Because if you see at the last few decades, what has happened during the last few decades, the science and technology has evolved considerably in respect of automation. A new thing is automation. And why this automation is required? To keep pace with the rapid industrial growth. If you get back to your 40s and 50s, where human labor was everything, then there was a growth, obviously, but the growth was not that much first. Once the automation has come, the new technologies have evolved much more quickly, and they have been implemented, and it has given rise to a rapid growth in the industrial. And this obviously giving a growth in economy as well. So what happened in earlier days, the automation was applied in such process industries. Obviously there was some automation, but they're applied in somewhat arbitrary fashion. Okay, and not much effort was given to make any real-time analysis of the process to ensure that whether this automation is adequate or not. Because in such cases, what happened, even if there was some automation, there has always been a human supervision, okay, to take care of that, and they always entrusted the human supervision to be efficient enough to take care of any situation. So That was their motto. The human supervision will be there, so any that will be the superficial loop, or it's a closed loop, superficial closed loop or supervisory closed loop system that was used. But as the production and productivity increased, it was beyond the capability of a single person or a group of person to maintain this sequence of operation or to maintain this process, this complicated processes. Okay, so this is due to the fact that this processes are day by day getting complicated. So they thought, okay, we should now concentrate on defining or designing the automation in a more precise way. And this was the occasion where the control engineers and the instrumentation engineers, they pounced the opportunity and they started devoting more time in designing the control system for such process and the plants thereof. And then became the process control, and they become much more popular. Okay, and now a lot of effort is given in process industries. And if you ask me, this control system is a very much integral part in the chemical engineering. If you have friends in chemical engineering, you see they have quite a lot of courses in control system, because in chemical processes the control plays a very important role. Okay, so this control system is basically a multidisciplinary, to be very frank. It's a multidisciplinary subject: electrical, mechanical, electronics, chemical. They all have these control systems. So it has a lot of opportunities to explore, right? So the process control loop, I'll discuss about the process control loop in the next class. I'll just give you an idea that why this process control have got so much importance in modern industry. Okay, so where I left off, so from that point, the process control engineers were given much more importance, and they were very much interested in developing new thoughts and new ideas, implementing new ideas into processes. So based on their experiences, they evolved certain rules based on some theoretical control, and these rules and control aspects, what they have done, they have enriched these process industries, and they have helped in this growth, the rapid growth in the industry. Okay, so the industry cannot alone could have this growth if only manufacturing of high-end machines were there. But to control that high-end machine or to operate that high-end machine with proper efficacy and productivity, you need some control engineers. The purpose of the control engineers will be to analyze the system, to design the system, and they also define the layout. They also define the layout, how this should be placed in a process plant, or a process bench, the different locations, so that to optimize the resources. Okay, so that I'll discuss in the next class, how this optimization or this process planning and the loop design is done. Now, what I'll discuss today is that this automatic control that has gained a lot of importance in modern days, and it has improved in leaps and bounds. Okay, that what they have to offer. Okay, what advantages they have to offer. So what, first and foremost, they offer enhanced process safety. Now this is very important, because in recent years, not recent years, in the first few decades only, this human safety has become much more important. Okay, because whenever you're working with heavy machinery, complicated machinery, you should always ensure human safety, not only human safety, the safety of the entire process industry. Okay, for that purpose, the process control engineers or the automation plays a very important role, or automatic control, I should say. Next is, I'll start from aspects that may not seem very important at first sight, but if you give it a second thought, you'll see that these are also very important. So I'll start with safety, then environmental constraints. See, nowadays the environmental constraints on industry are very much strict. Okay, and that is obviously necessary, because you keep on growing industry. If the industry starts growing on this rate, it will be very difficult to maintain the environment. So environment constraints that has to also be satisfied. For that, what they normally do, the waste management, whatever the waste product of a particular industry, you can use them, you can recycle them or transfer them to another industry where they can be utilized. So this process, this streamlining of this is also a part of automation in some cases, because some of the industry, they always have this recycling process, and they always produces byproducts. So that was not the fact in the previous uh, era, I should say, where a lot of wastage was dumped. Right now, they are reusing this wastage. Third, most important, meeting the ever strict product quality specifications. The product quality specifications are getting strict and strict because of the market competition. Okay, if you are developing a manufacturing a particular product, you will be rest assured that within a couple of months, your rival company or manufacturer will develop the same product and will give you or will ask for some less money for the same product. Okay, so you have to always keep on improving your product. Okay, so this product quality, you have to improve the quality and maintain the quality is pivotal, but improving the quality is also important. So to meet this strict product quality specifications, this automatic control systems will be playing a very pivotal role, because it is not possible manually to maintain this entire process efficiently. Coming back to the next point, the more efficient use of raw materials and energy. Because first of all, in some of the industries, the raw materials are getting scarce. So you have to have more efficient uses of that. And energy, obviously. The more efficient you use the energy, the more profit you will also get. So this all leads to more profitability, because at the end of the day, the industrialists, they look at the profit only, how much profit they are making. Okay, so we have to improve the productivity while keeping all this constraint in mind, so that your profit is increased, right? So if I just, again, if I discuss this in a more lucid way, see, in recent years, the performance requirement for process plant, what they have done, they have become increasingly difficult to satisfy. Why? If I reiterate the same point, because of stronger competition. There are a lot of competition in every field, so they have to keep pace with the competition. The environmental and safety regulations, I think day by day they are getting more and more strict, especially the environmental regulation, and the rapidly changing economic condition. This is also important. The economic conditions play a very important role in these industries. So how much industrialist is willing to invest in a particular industry depends on the economic considerations. So these are the key factors that is in a that plays a pivotal role in defining the product quality specification. That is, keeping all these things in mind, we have to satisfy or we have to fix a product quality specification. Now, a further complication that may come is the fact that in modern industry, what we use is complex and highly integrated processes. See, in previous industry, you used to have few very simple machinery that was human operated. Now the trend is to go for more complicated, more complex, and highly integrated processes. So they're becoming more and more compact, but as they're becoming compact or multifaceted, they're becoming more complicated. So this, some cases, it becomes beyond any single human being, for a human being to control all these aspects of a particular instrument. So they have to have some proper automation. Okay, that has to be implemented. And this also becomes a very pivotal thing from industrialist point of view. Okay, so because in such plant, it is becoming very difficult. The main problem is that for such integrated and complex plants, it is very difficult to prevent disturbances from propagating from one part to the another unit. See, if you have a simple systems, you can easily estimate what the disturbances may be, or you can easily identify the disturbances and you can mitigate the effect, or you can eliminate the disturbance using suitable step. But if it's a much complicated system, first of all, identifying the disturbance is very difficult, and when you identify the disturbance, it has already propagated through next few stages. So it will adversely affect the output of the system. For this particular purpose, for this disturbance, so the disturbance plays a very, very important role in this process industry. Okay, so to mitigate the disturbance, we'll discuss about different control aspects, where the main concern is to mitigate or eliminate the disturbance or the effect of the disturbances. Now, why I'm concerned about these disturbances, because I think I should mention the fact that these process control systems are mostly regulator. or regulator system. Do you know this difference between a servo system and a regulatory system? Anybody? Nah. Servo, the term, if you follow the term servo has come from servant or servant in English. That means you will give a command and the system should follow that command. Okay. In regulatory system, command is fixed. There is no change in the command. Or you have given this is your desired state. You need to keep yourself at this desired state. Whatever be the situation, what disturbance may come. The process control is basically the regulator type. It has a command, but that command is fixed. We have to have this production and this rate. So there is no change. Whereas in the servo system, you have to follow a particular path. That is obviously time varying. So there is a variable command. But in regulator system, this process industry, that command is fixed, right? That's why in the regulator system, the disturbance plays an important role. Because only the thing that can change the output is a disturbance. Because all other things are kept within controlled environment. So a control engineer's part is to obtain a controller which not only identifies the disturbance but mitigates or eliminates its effects as soon as it appears, so that the performance is not deviated from the desired value by too much, right? So given this, if I get back to my topic, because I have only 5 minutes to conclude, given this situation, that is with increased emphasis on safe and efficient plant operation, it has become only natural that the process control has become more and more important in recent years. Okay, so without this process control, and which mainly includes digital computers now, it will be impossible to operate such modern plants safely and obviously profitably. This profit is very important. If you are not getting any profit, then the industry will not grow. So this profit you have to also ensure, right? So if I summarize, the primary objective of a process control is to maintain a process at the desired operating conditions safely and efficiently while satisfying environmental and product quality requirement, and ensure quality of the product and the productivity at a desired level. Okay, so this is a summarize. So you have to have a desired operating conditions which have to be maintained safely and efficiently with keeping all the safety and environmental aspects in check, and the product quality that should be maintained. And at the end of the day, it should give enough productivity so that the industrialist or the investor is getting enough profit. Then only it is going to see a growth, right? So all these aspects, who determines all these aspects? The control engineers. They design a proper control system. It depends on the experience. So how they design a proper control system that may take care of all these points and give you a controller that will serve your purpose. Okay. So our objective or our goal will be to give an, obviously we will not be designing any controller for a plant or process, but we'll be discussing about different aspects of this process control and the design of process control equipments. I should say equipments or process controllers, because in process control there will be two parts: the process control equipments and the instrumentation part. The instrumentation part will be covered in the other part. So I will consider the process control theory and the application. Okay, the different modes of process control that will be used depending upon your requirement. Okay, and their applications, where they should be applied, where they're applicable, where they are not applicable. These things will be discussed in my part. So the next class I shall discuss in more detail about a proper process control system. Okay, starting from block diagram and their different definitions, right? And we will discuss more about the types of disturbances. Okay, what are the types of disturbances and things like this. So any
Okay, sir.
questions in today's lecture? Okay, it's a very lucid introduction. I have not given any mathematics, anything. I just wanted to share some thought on the process control and why this process control is so important, right? Okay, if you do not have any question, then we should conclude the class. Okay?
Yes, sir.
Okay, sure. Thank
Yes,
you.
sir.
And
Sir,
yes.
Sir, you will provide the notes later on in the in the classroom only, Google Classroom, or we
Yeah,
have
in
to?
the Google Classroom only. Google Classroom
Okay,
only. In the material section,
okay,
you'll get the note. Okay, and in when proper, I think the time will be proper. I will give you the note. Okay.
okay, sir. Thank you.
Okay, Anish, you just talk to NM sir huh, about this 5 p.m. class,
Yes,
and
sir.
you
Yes, sir.
inform me in the evening. You can contact me over WhatsApp. Okay, if you do not get me over phone, you can simply message me over WhatsApp.
Okay, sir.
Okay.
Okay, sir.
Okay, sure.